Hello ladies and gentlemen, this is Steve Gilbert and this is the solution video for the Monday-Wednesday section of CS 150 Fall 2019 Programming Exam number 3. For this programming exam, you are expected to write two functions that use loops to solve particular problems. One was simple and one was intermediate. Or even difficult. And so I'm going to give you a solution to these, and then you can look at them and study them and make sure you understand how we got the solution we want. So here's the problem for number 1, the simple one, P1. We're given an input string and a non-negative integer n. We'll say that the front of the string is the first 3 characters, or whatever is there if the string is less than 3. We're going to set the result to n copies of the front. And so for this, you're going to need to write a loop. And so you remember your loop strategy. So what we're going to need to do, step 1, is we're going to need to say, what do we want for output? How many times do I want to go through this? Or what is the bounds of the loop? So the bounds of this loop is we're finished when I have n copies of the front of the string. So I'm going to say while copies is less than n. Okay, so that's my loop condition. I have done step 1 of my loop building, and we should always do this step by one, the bounds. Now, of course, if I try and compile this at this point, it says I don't know what copies is. And so step 2 is always to go before the top of the loop and make sure that we have set up what is used in the bounds in this part, which is called the precondition. So we'll say int copies equals 0. I don't have any copies yet. The loop is about to start. Will it enter at that point? So this is the bounds precondition. Now let's see if we can compile it now. Yes, we can compile it. I'm getting a warning because I haven't used str here, but that's okay. Now, will this loop stop if n is anything other than 0? And the answer is, of course, not. If n is 1, 0 will be less than 1. We'll go through the body of the loop here, and when we get back to this, 0 will still be less than 1. And so we have to change something in the body of the loop. We have to advance the loop. We have to say copies plus plus. We have to increment it, move closer, or as we said in lecture 3, advance the loop. Now, at this point, we have the mechanics done. We can not only compile it, but we can check it. We can do go, and our loop will in fact end. As a matter of fact, we even got 13% because one of these cases I want 0 copies of that, and I do have 0 copies of it. So I'm going through the correct number of times. Now the second part of building our loop is figuring out what we want output. So I want n copies of that loop. I have result, which has no copies of it. And so each time through the loop, what I need to do, so this, by the way, was already done for you. This is step 4, the goal precondition. We've created a variable to hold our data. That means in the operation, we need to change that. So I'm going to say result equals result plus, and then I have to figure out how to get the front of the string. And it is the first 3 characters or however many is there. So we'll say str substring starting at 0 and going up 3 characters. If there's less than 3 characters, this will work fine. So this is step 5, the goal operation. Now, of course, we can do this slightly easier and shorter. as you learned in class, because we can also modify the object itself, modify the result. Now, after the loop is over, step 6 is, have we reached our goal? This is the post condition. And in our case, let's ask ourselves that. Okay, so I know that I got out of this loop because copies was at least n. So that means I have done this step n times, and each time I've added this to result, and so I can say yes to this question, and the result will hold my answer. So let's compile that, and let's go ahead and check it out here. And we can see that we have 100%, or 25 out of 25 for the first problem. Now, the second problem is a little more difficult. What we're going to do is we're going to find, we're going to set result to the length of the largest block in the string. What do we mean by a block? A block is a run of characters, adjacent characters that are the same. So OO is a block here, and it's too long, and it's the longest one. BB is a block, it's too long, but CC is 3 long. DD is too long, so we don't care about that. BB is also 3, but it's not larger than the largest we have so far, so 3 is the correct answer. So first, what we're going to do is set up our bounds. What is the bounds for this? What kind of loop do we want to use? By the way, in the previous example, we could have used a for loop exactly as easy. So what we want to do is ask ourselves, do we need to visit every character? The answer is yes. And so the simplest loop we have for visiting every character in a string, where we don't need the indexes of the string, is simply write a iterator loop. Use the loop that goes through for character C in string, do something with that character C. So I'll do that first. That's relatively easy. And so I will say for char C in str. So this sets up the bounds automatically and advances the loop. So this will get the first character out, then the second character, then the third character, and so forth. And it also sets up the loop correctly. So it does step 1, 2, and 3 automatically, so we don't have to think about them manually. Yeah. So now let's go to step 4. It does result before this loop. So result, we've already created the variable, step 4 for our output, but does it contain the correct answer? And the answer is we don't know. It's a undefined value. It's uninitialized. So the first thing we have to do is set it to the correct output value. Now, are we going to need to know anything else in here? Well, now in the operation, we need to start thinking about what's the algorithm here. And so the algorithm for a run is that it is a character that's adjacent. Adjacent means the character before it was the same. And so we can put this in pseudocode. We can say if the character is the same as the one before, then what we'll do is add 1 to this run of characters. And if it's not the same as the one else, or otherwise, then we know that we have only one copy of the character we've read, and the previous run was possibly the largest run. So if the previous run is larger than the largest, then what we'll need to do is save the if the current run, I'll call it the current run, then save current as largest. Then we've only read this character once, so we need to set the let current run be 1. I've read one copy of this character. And let's see if we need to do anything else. Let me walk it through my mind. No, I think for the operation that's pretty good. So again, this is the part for the operation we have to think about it. And in thinking about this, we have to figure out, I need to know what the character before this is. I need to know what this run of characters is. And so we need variables for that. So I'm going to call the character the one before, I'll just call it previous. I'm going to set it to a value 0. Now 0 is the ASCII character of that, and the ASCII character 0 would not appear inside the strings we're looking at. And we couldn't set it to A or B or C because it might appear inside one of those strings. Now I haven't entered the loop yet, and so my largest run is going to be 0. I haven't entered the loop. So here's, I need the largest run too. So I'll have int largest, and this is going to be the current run. I'll call it cur run, like that. Okay, is that everything mentioned in the pseudocode? I think it is. So let's put this into code. Rather than trying to put the characters in between, I'll put them here. So if C is the current character equals previous, then all I need to do is do cur run plus plus. Okay, if that's not the case, we have several things to do. If cur run is greater than largest, then largest equals cur run. Then we'll say cur run equals 1, and we'll reset it. Okay, it looks to me like that's everything. Largest is actually result. So I actually don't need largest. So result is going to be my output. Result is 0 before. And so I can change in my thing here, result. So result is what's going to change. Okay, let's see if it compiles. Let's not go any further. So if cur run is less than result, greater than result. So again, I have some syntax errors. Okay, that compiles. Let's clear the output and do go on it. We already know problem 1 is okay. Let's see about problem 2. Okay, it seems to succeed on that one. That's pretty discouraging. It succeeds to succeed on this one. So that means that the longest run out of this is going to be 1. So if we don't have any before 1, it seems to do okay. If we have more than 1, it doesn't seem like we're adding the numbers up correctly. So let's see if we've made a mistake in our algorithm. And let's just take a little example like this. Here's 1 and 2. The first time we come through, x will not be, oh, I see the problem. So what happens is after we set the current run to run, we need to set the previous to the current character. So this character has had a run of 1. The next character we look at, this should be the previous. So previous equals C. Okay, it looks pretty good. Let's compile it. Let's clear the output. Let's do go. Okay, so now 2 works okay. This one obviously has a 3. That works okay. This one fails. This one fails. Only 2 of those fail, so that's actually pretty good. It's 90%. I've got 96% on the whole thing. So let's see why these 2 are different. So if I look at this one, it's actually pretty simple. 2 should be the largest, and it doesn't print 2. I'm sure it prints 1. This one, the largest should be 1, 2, 3, 4. And so what's the same about these 2 is that the largest one appears at the end. Well, imagine that we have counted up, so current run is 4 in this case, and then we run out of characters. In other words, we get to the end. Is there any place where we set the result to current run? No, there is not. So this is a case where after the loop is over, we have to handle the post condition. So we didn't handle the post condition before, but if the loop gets out and the largest number is calculated at the end, we have to save that in our result. So result, if cur run greater than result, then result equals cur run. Okay, and so that gets us 100%. We have all of those correct. And I'm going to show you, since we have a video, I can show you a couple other ways to solve this. And so I'm going to select all this code. I'm going to comment it out like that. And I'm going to use a different method that doesn't require us to, I'm going to use the same algorithm, but a different method that doesn't require us to use that kind of loop, the iterator loop. So I'm going to use the loop you're familiar with. I'm going to say for size t, I equals 0, I less than len, we need, right? Len equals stir size. I less than len, I plus plus. And so all of you have memorized this. It's pretty easy to simply memorize it and write it down. So that is the mechanics of that loop. That will visit every element, just like these are the mechanics of that loop. Basically, it's the same thing, but now we have an index. We can select items by index. So instead of C, what we have is stir at I. So if stir at I is the same as the one before it, we're going to add 1 to the run of these characters. But if stir at I is the first character, like this one, there is no 1 in front of it to check. So we're going to have to do an if statement that handles both of those situations. So if I is greater than 0, at that point I know I can check before it. And stir at I is equal to stir at I minus 1, the one before it. Then we're going to say run, cur run. Okay, now of course that means I'm going to need the current run. Okay, if that's not the case, we're going to have exactly the same situation we had before. If cur run is greater than result, then result equals cur run. Okay, and we're going to need to say cur run equals 1, and we don't need the previous part here. So in one sense, that's a little bit easier. So let's try this one. This is a little shorter than this one down here, but it's the same algorithm. We're simply using the index. And a regular for loop to check it. Okay, just like before, I got several that passed and a couple that failed. This fails because this is the end. So even though this is a for loop, it doesn't mean we don't have to handle the post condition, and we do. We need to say if cur_run is greater than result, then result equals cur_run. So in each of these cases, I've used all 6 steps. I figured out what makes the loop go around. In this case, it's easy because I can memorize that. In this case, it's easy. I can memorize that. I've thought about the data that is needed. So in this case, I've created a result. Then I've thought about the algorithm. I wrote it out simply in pseudocode here. And then I looked at the pseudocode to see what additional helper variables I needed, and I created those up here. Now in this version, I needed to create a previous character and save it each time through. In this version, I did not need to do that because I could use the index to look at the one in front of it, but I did have to make sure that I didn't do that to the first character. So I could only do it when it was the second one. So let's see if we've got that. Let's go on this. And we'll see that now we match that perfectly. I hope this helps, and I will see you in class next week.